There are many ways to run our programs in Java. One way is this cute trick I do in my text editor where I press a keyboard shortcut and the output appears on the bottom. But let's focus on a workflow that's a little more general that we expect you guys to get comfortable with in this course. So in this workflow, rather than doing some kind of magic text editor tricks, we're going to work from a terminal in our operating system. Now, this is not a Windows or a Mac OS or a Linux class, so we're not going to go through the terminal in great detail. And we're assuming that you have some familiarity. But what I do want to say is that if you're going to go and do a lot of programming in the future, this is really something you want to get acquainted with. That is, using the terminal on your operating system. So the usual way, or the most basic way, to compile and run a Java program is as follows. So I'm in a folder, and I use the ls command to list the current files. And I see there's a file called helloworld.java. I want to run that. So it's actually a two-step process. And so what I'm going to do is I'm going to type javac hello world, and so forth. Now, quick tip, rather than type out helloworld.java, there's a neat trick where you push tab and it autocompletes. So use that. So I do javac helloworld.java and press enter. So now I'm here, and it seems like nothing's happened. But if I do ls again, I see a new file has appeared called helloworld.class. What I've just done is compiled this .java file and turned it into a .class file, and the old file remains. Okay. Now, if I now want to run hello world, I type Java without the C. C means compiler. So I'd write Java hello world and press enter, and it does whatever the program's supposed to do. That is hello world. So this Java program needs this class file to run. If I remove that file and try it again, so if I do Java hello world, now I get error could not find class hello world. So if you're using the command line compilation, using just the basic tools, javac and Java, you'll first need a javac and then Java. And so to elucidate a little bit more of what's going on, I'm going to use the cat command to print out what's in hello world. Here's the code. What hello world.class is, it's just another file. But instead of having symbols typed out that you and I can understand as humans, it's a bunch of weird, strange symbols that were generated by the Java compiler. So some of it makes some sense, but a lot of it just seems like garbage characters. So let's see a schematic view of the whole process. So compilation, when you run a Java program, the usual thing you're going to do, it's a two-step process. You do hello.java, give that to a compiler, and it generates a .class file. That .class file can then be given to an interpreter, and then stuff will happen. And it could be anything. It could be printing out output. It could be playing a song. It could be deleting everything on your computer. It could be restarting your computer, sending an email, whatever. The interpreter takes the class file and does whatever it's supposed to do. That's not the only way that you could ever run Java code, but it is the most normal thing to do. Even my little text editor trick where I run things like so, it's really doing this. You just can't see all the intermediate steps. Okay? But you could, in principle, write an interpreter that's able to directly interpret .java code, but the powers that be have set up the standard process so that there's an existing compiler tool that creates class files that can be interpreted. So why? Why, oh why, would we ever do hello.class? Why would we want to make such a file? Well, one reason is that it's been type checked. Now, if you're reading the book, we haven't talked about static typing yet, but if you've seen static typing already, what that means is that when we give out our application to the world, we don't give everyone our .java file. We give them our .class file. And because it's been type checked, that keeps us safe from type errors, and thus our distributed code is safer. Next is that .class files are simpler for the machine to execute. And this is for reasons that are a bit beyond the scope of our class. But let's just say that it's a little harder to write an interpreter that efficiently interprets code like this compared to this. Right? So this has already been kind of pre-chewed a little. In the same way that I guess eating a bunch of pre-chewed jelly beans is a little easier than solid jelly beans in a bag, so too you can think of this as a little bit pre-chewed. And then lastly, there's this minor benefit that since you're not giving out your .java file, nobody knows exactly how your code works. It protects your intellectual property a little bit because you can just give out the .class file. Now, it's not a great benefit because there are actually tools that can take a .class file and give you back a .java file. It's not the exact .java file, but you shouldn't think of it as some kind of great security or anything. Okay? So if you're curious about the compilation process, you don't really need to know very much about it except for these points. But if you're curious about how exactly a compiler works and so forth, There are other courses, CS61C, as well as CS164 that you can check out, but we're not really going to say much more about it, and we're just going to proceed from here.